Alright, today we're looking at section 9.2, which deals with Pythagorean theorem, which most of us should be familiar with at this point. If not, Pythagorean theorem, theorem 9.4 says in a right triangle, the square of the length of a hypotenuse is equal to the sum of the squares of the lengths of the legs. So, if I take the length of the hypotenuse, remember in a right triangle is the side opposite the right angle, and that is represented by C. Formula C squared equals A squared plus B squared. A and B are both going to be the lengths of legs, so the square of the length of the hypotenuse is going to be equal to the sum of the squares of the two legs. The converse of that is going to say if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then we know the triangle is a right triangle. So basically, if it fits into the formula C squared equals A squared plus B squared, it works, we know it's a right triangle. And then something known as a Pythagorean triple. It's going to be a set of three positive integers, a, b, and c, that satisfy the equation C squared equals A squared plus B squared. So if the lengths of my three sides of the right triangle are all integers, then it works as a Pythagorean. Alright, so let's look at a few triangles and use the Pythagorean formula here. So find the missing length. Do the side lengths form a Pythagorean triple. We're going to solve for the missing side, and then if all the sides are integers, then we know it's a Pythagorean triple. So the first one, remember we are using Pythagorean's theorem. So C squared equals A squared plus B squared. And so in the first triangle there, the x is our hypotenuse. So we're going to say x squared equals the two legs squared, 3 squared plus 4 squared. So x squared equals 9 plus 16, which becomes x squared equals 25. And then solve for the x. Take the square root of both sides to get rid of the square. And it's going to give us x is equal to the square root of 25, which is 5. And so if I look at the side lengths, I've got 3, 4, and a 5, all of which are integers. So this one would be a Pythagorean triple. Alright, so then over to the right, got x, 5, and 13. In this case, the 13 is our hypotenuse, so 13 squared is going to equal x squared plus 5 squared. 13 squared is 169, equal x squared plus 25. Subtract 25 from both sides. 144 equals x squared. And take the square roots of those two sides to get rid of the x, or the square on the x. And 12 equals x. So once again, 12, 13, 5, all integers. So that is a Pythagorean triple. Alright, so now the one in the middle. So across from the right angle is the hypotenuse, so 6 square roots of 5 is our C. It's going to equal 12 squared plus x squared, our two legs. So 6 square roots of 5, if I square that, it's going to be 6 squared, which is 36, times square root of 5 squared, which is 5. 36 times 5 will be 180. 12 squared is 144. It's x squared. Subtract the 144 from both sides. We get 36 equals x squared. And take the square root to get rid of the square. and our x is going to be 6 in this case. If I look at my three sides, I got a 6, 12, and 6 squared roots of 5. So this one right here being 6 squared roots of 5 is not an integer. So this one is not a Pythagorean triple. So then down to the bottom left, we got 9, 6 squared roots of 10, and x. Across from the right angle is the x, so that's our c. X squared equals 9 squared plus 6 squared roots of 10 squared. It's going to give me x squared equals 81 plus 6 squared is 36 times square root of 10 squared, which is 10, 360. X squared is going to equal 441. Take the square root of both sides. It's going to give me x equals 21. So 21, 9, and 6 squared roots of 10. The 6 squared roots of 10 is not an integer, so this one is not a Pythagorean triple. And the last one over there to the right, again across from the right angle is the x. So that's x squared equals 2 squared plus 3 halves squared. Give me x squared equals 2 squared, which is 4. If I square 3 halves, that's going to be 9/4. Now I've got to get that in 4 in terms of fourths, so I can add that to 9/4. So multiply top and bottom by 4 to get a 4 in the denominator. So x squared equals 16/4 plus 9/4. So I can add those. 16 and 9 is 25/4. Take the square root of both sides to get rid of the square on the x. And 25 and 4 both have a square root, so that's going to leave me with x equals 5 halves. And so if I look at my side lengths, 2, 3 halves, and 5 halves, these two fractions are not integers. So once again, this one is not a Pythagorean triple. Alright, so that's the Pythagorean theorem. Now we're going to use the converse of the Pythagorean theorem to determine whether or not these triangles are right triangles. Because if they are right triangles, they still have to fit into the Pythagorean theorem, right? C squared equals a squared plus b squared. And we don't know if they're right triangles, so for the hypotenuse or the C term, we just insert the longest side, the largest side that we have. So in this first one, the longest side is 97 squared is going to equal the other two sides squared and added together, 72 squared plus 65 squared. And so if I square those, 97 squared is 9,409, 72 squared, 5,184, and 65 squared, 4,225, which is going to give me 9,409 equals 9,409. So those do equal each other. So all three sides fit into the Pythagorean theorem, which means that this has to be a right triangle. All right, the next one over there to the right, The longest side that I'm going to use for my C is 89, so 89 squared is going to equal 39 squared plus 80 squared. 89 squared, 7,921, equal 39 squared, 1,521, plus 80 squared, which is going to be 6,400. There's 3921 equals 1521 plus 6,400, which is 7921. Those actually equal each other, so once again the side lengths fit in the Pythagorean theorem, so this has to be a right triangle. Alright, so then last one here, we've got 20, 13, and 4 squared is 35. We have to figure out which one is the longest side, which 20 is the longest side between these two, and the square root of 35 is almost 6, because the square root of 36 would be 6. So if I did 6 times 4, that would be 24, and so it's bigger than 5, and 5 times 4 is 20, so this would have to be the longest side. 4 squared is 35. So that's what I'm going to put in for my C. 4 squared is 35 squared, and I have to equal 20 squared plus 13 squared. So 4 squared is 35. If I square that, it's going to come out to be 560. 20 squared is 400, and 13 squared 169. So I get 560 equals 569, which is close, but they're not the same. So since those are not equal, that is not a right triangle. Alright, so moving on. Theorem 9.6, Theorem 9.7 deal with helping us to determine if we have 3 side lengths and they don't make a right triangle, what kind of triangle do they make? So, Theorem 9.6 says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the 2 other sides, then the triangle is acute. So if I square the longest side, and that is smaller than the other 2 sides squared and added together, then I have an acute triangle. On the other hand, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other 2 sides, then the triangle is obtuse. So in this case, we want to make sure that we're putting the C term on the left, just so we don't get confused between less than and greater than. Alright, so if the C squared is less than A squared plus B squared, it's an acute triangle. If C squared is greater than A squared plus B squared, then it is an obtuse triangle. So here we want to decide whether the numbers can represent the side lengths of a triangle. If they can, classify the triangle as a right, acute, or obtuse triangle. So first off, if we remember back at the first semester, in order for 3 side lengths to represent a triangle, any 2 sides have to add up to be greater than the third side. And so this first triangle, if I check 2 plus 10, those 2 sides added together have to be greater than the third side, which is 12. And 2 plus 10 is 12. And is 12 greater than 12? It is not. Since 12 is not greater than 12, it's the same. This is not a triangle, so we don't even check that one to see if it is a right, acute, or obtuse, because it's not a triangle at all. Alright, so the next one, a little more complicated to figure out. Right, 4 plus 5 is going to be greater than 5. That's 9 is greater than 5. 5 plus 5 is greater than 4. 10 is greater than 4, and then we just have another 4 and a 5 to add together. So in this case, the two sides added together would be greater than the third side. So it is a triangle. So now we want to figure out what kind of triangle. Now we have two sides that are considered the longest side, so we're just going to pick one of them and call it C. So I'm going to call that C, A, and B. So 5 squared. I'm just going to put a box here because we want to compare. We don't know whether it's equal, greater than, or less than right now. 5 squared plus 4 squared. 5 squared is 25. We're going to compare that to 25 plus 16, or 25 compared to 41. In this case, 25 is greater than 41. So C squared is greater than A squared plus B squared. So that makes this an obtuse triangle. Because, right, and that makes this an acute triangle. Because that is not greater than. Wow. Is less than 41. Don't go too fast. So that is an acute triangle. 26, 10, and 17. If I add 10 plus 17, is that greater than 26? 27 is greater than 26, so that works. And it should work for the others, but we can check them. 26 plus 17 would have to be greater than 10. 43 is greater than 10, so that one definitely is bigger. And so we can also do, so 10 plus 17 is greater than 26. 26 plus 17 is greater than 10. And 26 plus 10 is greater than 17. 36 is greater than 17. So that works in all cases. Any two sides added together are greater than the third side. So it is a triangle. Now to figure out what kind of triangle. 26 is our longest side, so 26 squared compared to 10 squared plus 17 squared. And 26 squared, 676. Comparing that to 10 squared, which is 100, and 17 squared, which is 289. So 676 compared to 389. In this case, 676 is definitely greater than 389. So now in this case, yes, our C squared is greater than A squared plus B squared, which makes this an obtuse triangle. Alright, so that completes section 9.1.